everyone, welcome to another PSC session. Today we are going to discuss a problem named e to power x. So let's go to the description part. One famous thesis says e to the power x is equals to 1 plus x squared by 2 factorial plus x cubed by 3 factorial plus x to the power 4 by 4 factorial and so on. Okay, so the actual says from n equals to 0 to infinity, sum up by calculating this fraction x to the power n by n factorial. But there is a bit change here. Using the Boolean explanation for another term e to the power x, calculate the value of e to the power x for given x and n. Okay, do not calculate it directly using the formula and do not write any iterative code. So we need to write a recursive code for this, and for the given x and n, the formula will become like this. Okay, let's write the givens first. Given for given x and n, calculate e to the power x equals to 1 plus x squared by 2 factorial plus x cubed by 3 factorial till x n by n factorial. Okay, and we need to write a recursive code. Okay, so let's move on with the episode. If the formula is given like this, okay, and so this can also be written as this, right? Either we sum up whole things from left to right or right to left. The final value of sum won't change, right? There will not be any change. So we can write this formula like this one also. And in this too, when we moved on after, or you can say before x square, okay. So what is this x actually? This x can be written as x to the power 1 by factorial 1, right? Because x to the power 1 will become x only and 1 factorial will become 1 only. So in actual, all in all, x to the power 1 by 1 factor will become x only, right? So that's why this can be written as this, and for 1 this one. See, anything to the power 0 will become 1 only, okay? Anything to the power 0 will become 1 only, and 0 factorial is also 1. So if we do this, x to the power 0 by 0 factorial, what will it become? 1 by 1 only, become 1. So this can be written as this also, okay? So this is just a simplified version of the formula of the formula, so that we can still relate with x and n till the very end, okay? Okay, so let's move on. So basically, now what is recursion part? Okay, so where do we use recursion? We use recursion when a problem can be broken into sub-problems, okay? So how to find what are the subproblems in this formula? Okay, let's see. The formula is like this. Okay, so here the subproblem is to find the values of the constituents so that we can add them up and find our final sum, right? So what are the constituents? See, the value of this fraction added with whatever fraction lies between this part, and then this fraction, I mean, the sum of all these fractions will give me the final sum for e to the power x, okay? And what are these fractions? These fractions are nothing but our sub-problems, okay? Okay, so if we solve all these sub-problems now, which we can also call it constituent problems, okay? Or sub-problems, then add them up. This will give our final answer, right? So that's the approach we are going to use. So let's say moving on with it. For example, x equals to 4 and n equals to 2. See, it's given in the sample input also. So that's what I have taken. Okay. See, the formula will become, I mean, if it's just x power n, okay. So if it is, I mean, x is 4 and n equals to 2, then it will become 4 to the power 2 divided by 2 factorial plus 4 to the power 1 divided by 1 factorial plus 4 to the power 0 divided by 0 factorial, okay. Same thing, 4 square by 2 factorial plus 4 plus 1, okay. Now, so if we have a function exp42c for x equals to 4 and n equals to 2, we have a function exp42. Okay, so as I said, we will be calculating these fraction values, right? What is that? 4 to the power 2 divided by 2, because n is 2 na, it's nothing but x to the power n by n factorial. Okay, because x equals to 4 and n equals to 2, so it will become 4 to the power 2 by 2 factorial, right? There's nothing else in that. So this will give me the solution for my sub problem. But what next? Next is, as I already showed you here, once I have the value of this problem, okay, the next thing we are doing is we are adding with what? With the value of other subproblems, right? What are those? These are these. Okay. So we need to continuously add the value of other subproblems also. So what are we going to do next year? Add. What is our next subproblem? Next subproblem is going to be x is going to be same, but n will be decremented by 1. That's what we saw here in this formula. Na? N was decremented by 1, then 2, then 1, and then 0. It became like that, right? So that's why exp4 comma 1, what will it return? It will return 4 to the power 1 divided by 1 factor plus again another subproblem. What is that? Exp4 comma 0. Okay, so again 4 to the power 0 divided by 0 factorial plus again next is subproblem. What is that? 4. Then because n is decrementing by 1 continuously, so 0 minus 1 will become minus 1. Okay, and it will go on like this. Okay, so the sum will become like this. I mean, if we just add up all these things, right? Adding, and adding, correct? And so on. So 4 to the power 0 by 0 factorial plus 4 to the power minus 1 by minus 1 factorial. It will keep continuing because n is decremented by 1. So isn't it, I mean, a bit different than what is actually required? Because in our formula, we just saw that now. That we are stopping when n becomes 0, right? So here also we should stop. But how to stop? Because we have designed our function that way. We wrote it like n will just decrementing. So see here, writing a recursive function have two parts. Okay, first is base condition, next is logic part. Logic we already saw, like finding the fraction and things. Okay, base condition is like where your code will start, not start, actually stop. Okay, where recursive calls stop means recursive calls are nothing but function calling function. Okay, so when do they stop? That's decided by the base condition. And what is that base condition? Minimum valid input. Okay, like from here we can see that we all only wanted till 0, because after any 0, anything smaller than 0 is just invalid for me, right? That's undesired. So now we saw that where we need to stop, right? So that will be put on in our base condition. What is that? N equals to 0 is our base condition. Okay. And that's how we are going to write our code. So let's move to the pseudocode part. So this is my functional prototype, expx comma n. This is my base condition where my function is going to stop, or I mean, moving back. Okay, start moving back, return 1. Okay, so if n equals to 0, return 1. That's all. Okay, and other part, and now I am going to calculate the value of the fraction. Okay, so by first I am calculating the x to the power n part. Okay, it was na x to the power n by factorial n. So value is nothing but calculating this part, and then answer is value divided by fraction. X to the power n by factorial n was there, right? So value is this part, and answer equals to value divided by factorial n. Okay, so that's what it is happening. Okay, and once I have calculated this fraction part, then what I am doing, I am returning the value of that fraction part plus the value of my sub problem. Okay, then it will be calculated, right? Because it's a recursive call. Okay, with n minus 1, right? So that's all for this function, but here there is a function called factorial n. So I know you know, you already know the logic, but still I'm writing. Okay, so it's factorial n, factorial of 0 and factorial of 1 are equals to 1 only. Okay, so that's why in this base condition, if n equals to 0 or n equals to 1, it is 1. There is no factorial for negative numbers. Okay, so that's why this is the base condition only, and the other part is for n into factorial of n minus 1. Okay, that's how the factorial will be calculated. Now let's take an example, a proper example. Okay, export n2 exp42, how will it run? Okay, so it will return 4 is x, right? So 4 square factorial 2 plus exp 4 comma 2 minus 1 1. Okay, it will go like return 4 to the power 1 divided by 1 factorial plus exp of 4 comma 0. Okay, 1 minus 1 equals to 0. Now what will happen here? Return just a 1 only, because this is my base condition, which is met up right now. Okay, so ultimately it will become, if I have to simplify it, return 4 square by factorial 2 plus 4 plus 1. That's all. Okay, so I hope you got the whole idea of this question, how we reached to the solution and how we wrote the our recursive code. So people, thank you. That's all for this session. We'll meet in the next session. Till then, bye bye.